My name is Claes Redestad. I'm from the Java platform group at Oracle. We are a small group of developers sitting in Stockholm, working mainly on Hotspot runtime, Hotspot compiler, and Hotspot GC in garbage collection. But I'm in the performance team where we, act as a both research and development team on our own, but mainly as a support organization for the various development teams, ranging from core libs to hotspot runtime improvements, etc., etc. So today I'm not going to talk too much about performance though, but rather give you a small tour of this small little project called Java 9 that we've been working on for some years now. Before I say anything more, there's the obligatory safe harbor statement, which tells you that you shouldn't trust anything that I'm saying, or especially not make any commitments or other whatever. Yeah. So this small little tour. Can everyone hear me all right? Good. Thanks, Ruud. So this tour we'll try and look at the language changes, the tooling changes, and the more, in my opinion, more exciting changes to the libraries, various performance improvements, and if we have time, I know we have a 40-minute slot here, so I'll try to sweep through the landscape swiftly. There are always more things to cover. Java 9. I don't have the number now, but we have an enhancement proposal process in the OpenJDK community called JEP or JEPs, and I think we have like 200 different JEPs plus delivered for Java 9, and those range in scope from this small little module system to like change some detail in the client renderer or whatever. But I'm not going to bore you with a list of these things because they are, very, very detailed in technology. So first of all, I'm not the first to make a talk about Java 9. There are lots of resources out there. You can Google for Alan Bateman, Alex Buckley, Joe Darcy, or Simon Ritter from Azul, who are happily doing traveling the world and doing talks about Java and Java 9 in particular. So here I'm trying to give a summary of things that I've been involved in myself and that I think are interesting in the platform as it's been developing. Is that me? So the language changes in Java 9, on a syntax and syntax level, they might not be very exciting, but I would say that the structural changes wrought upon us by the module system is even though it doesn't change syntax very much or anything at all, it changes the language at its core. And has been a long effort involving many of the architects and people involved. Mark Reinhold, the chief architect of the Java platform, estimated that he's been spending like 12 years on this now, and 9-10 years as a formalized project. So it's been a Herculean effort to modularize the JDK, and of course, some people might ask if it's worth that investment, but from a low level or from a code and product centric view, there's a lot more to modularizing the JDK than meets the eye. It's allowed hundreds and thousands of cleanups to the core libraries, to modules, to separate and disentangle. Like you had logging dependencies on client libraries and desktop and headless whatever. So you had various undefined and or hard hard to disentangle dependencies from code all over in the JDK. So you touch one class, and all of a sudden you have a web server, or the scaffolding for the web server loaded into memory, etc. So there's been many engineering years spent into disentangling this and cleaning up things without breaking, or hopefully not breaking, compatibility with user applications. So a JDK contains about 100 modules. I should have said roughly because it varies a little bit from platform to platform. There are like ucrypto modules on Solaris that doesn't exist on Linux and Windows and similar. This image this image is actually taken from the Javadoc. So if you go to the Java 9 Javadoc and look at the different modules, you'll see graphs of dependencies between them. That's pretty nice. I'll look through that later. One problematic consequence of the module system is that there are modules put into the JDK historically that never really belonged in the JDK. They came from Enterprise Edition and were added in by some policy to try and make applets easier to interop with the state-of-the-art enterprise systems of the day, which goes back to Java 1.2 days when people built a system in Java Corba, and SOAP-based web services was the primary means of interacting with other systems. So these modules are problematic in that they might conflict with similar or exact same modules provided by, say, an application server. So by default, these 5 modules or these 6 modules are not enabled by default. You have to explicitly enable Java Corba for it to be available, and they will be removed, in a future release of Java of the JDK. So on a language level, there's of course there's a new grammar for describing modules. So you can add the module-info.java to your project, and the module descriptor allows for, this is an example from the JDK itself, where you have a module that describes JDK.management, which is a JDK extension of the Java management module, so it requires transitively the Java management. Transitive means that it will export the things that Java management exports, and it will also export ComSum management, that's the package, etc. So the module graph or the module descriptor allows for describing the module graph, but this is all I'm going to say about modules, because there are much more interesting things. I would defer to Alan Bateman and Alex Buckley's rather long but very informative talks on this topic. I'll post the slides later and you'll see the links, but they're easily found via Google. So let's go to real language changes. Java 9 is a little bit scarce on syntactical or changes to the Java language itself. We have improved try with resources as one of 4 features. And this basically allows to take advantage of the concept of things being effectively final. So javac currently, sometimes you have to create something new or make sure that something is final, but sometimes javac can infer from context that this input stream in the reference is never changed, so you can do more with it than it could previously. So this is just an extension of making sure that effectively final variables can be used in try statements, and that this will, of course, close the input stream once you exit the scope. other very small changes is that anonymous classes no longer have to qualify the generic argument on the right-hand side. Yay. The underscore identifier is now a keyword, so it's no longer a valid identifier. This is a future-proofing thing to make sure that in the future, maybe underscores will be used in generic style programming to denote things that are there but you don't want to care about, for example. But there's the safe harbor statement that says that I don't know what I'm talking about in that one. And the last one, when it comes to language changes, is that private interface methods are now allowed. Why, someone might ask? And well, Java 8 introduced default methods on interfaces, which is a very nice feature if you're developing a library consumed by others and you want to add extensions to to an interface. Previously, this was very, very hard to do before Java 8 because adding methods to something might break or will break both binary and source compatibility. What default methods added that, but default methods were like, yeah, but now I want to implement things that are shared between methods. I couldn't do that, so private methods just fills a little gap there. That's about it for Java language changes. I'm sure Kotlin will have more to say about the language niceties, but well, Java 9 has a lot more to offer on the tooling side and the library side. So first of all, the JDK layout or the JRE layout itself is just totally revamped. Modular runtime images comes in and replaces tools.jar and rt.jar, etc. So the JDK is much different. There's just fewer directories overall, but due to modules, the JDK downloads have grown significantly due to JMods. So JMods is a packaging format for modules used during the JDK build itself. It's not very, very interesting from a user point of view, but when you download your JDK, you have the JMods there. The particular each module is self-contained in a JMod, and those JMods can then be linked together into a runtime image. So modular runtime image means just the generalization of like a JDK is a runtime image, a JRE is a runtime image, and over time the concept of a JRE itself is going to fade into history, because you'll be able to custom design images fit for your purpose or your specific purpose that may or may not include some particular module. To go with all these modularization, Javadoc and other tools have been changed significantly. You have of course, some long overdue and nice HTML5 improvements to the Javadoc itself. You now a client-side search box, etc. You have the module graph visualizations, and module graph visualization, of course, hide a pretty nice feature that allows user extension to doclets to generate any kind of complex visualization or whatever into your Javadocs if you want to. Also, a small conundrum. How many here have ever been in a situation where you are compiling Java code on the latest platform but targeting a previous one? And how many have had a pleasant experience doing so? Well, I know like tools like Maven even lacked the ability for some time to even specify a boot class path JDK, but now of course they do. But many often forget to do that, and then you get warnings on the command line, and people are like, "Oh, I get these weird warnings, but I don't know why, and it kind of works anyway, so I'll just ignore them." And the thing is, what's happening then is that you're compiling for a previous release using the APIs of the current release. So you might be using APIs that are in the new release, but they didn't exist in the old one. So you might introduce ambiguities into your code because the APIs that existed in the previous release weren't there, and you're compiling against it with the new. So it might hit you as a runtime error if you're unlucky. So anyhow, the release flag simplifies a lot of these problems and gets rid of the need to have a boot class path JDK lying around, so you don't have to maintain, or your CI system might be very happy with this. This is of course not going to be maintained indefinitely. So Java 9 supports Java 7 thoroughly, and the idea was that Java 10 should then support Java 8 and going forward. But you might have heard about this 6-month cadence, where we are now going to release a new JDK every 6 months. So already in March, I'll be back and talking about Java 10. No promises. And then in September next year, we'll have a Java 11, is the current proposal, and so forth. So previous statements that that Java C should only support 2 major releases back might be subject to change. Might be more releases, more than just a year. Anyhow, other nice and interesting features, or complex and problematic, are the multi-release jar files, which allows applications to define different classes for different versions of the JDK. So if you have a library that is doing some workaround hack to make up for the lack of some feature in a previous release, you can do implementations that are picking up the new APIs in the new one and such. A little bit more perhaps complex than it really needs to be, but it allows for some neat use cases for library vendors to support libraries that pick up features from recent or the latest JDK, which ideally should help migration to Java 9, as libraries can publish one artifact that should be runnable on Java 8, 9, 10, and so forth. Apart from the big changes, Java 9 does a little bit of house cleaning. Some seldom used tools in the binary executables directory are now gone. Some have been merged into other tools or replaced, and JVisual VM is no longer shipped with the JDK. It's still downloadable from a GitHub page. But Java 9 adds instead lots more to deal with the modularization effort, to deal with deprecation scanning, finding dependencies. So you have JDEPs is a pretty cool tool or pretty easy tool to play with on your artifact and on your code to verify that your code or that libraries that you're using aren't transitively trying to poke holes into the JDK internals, for example. This one exists in Java 8, but is of course improved now with with a more complete image of what's in the modular image. So you have then Jmod, JImage, and jlink are a little group of tools for well, the first two is mainly for people building the JDK itself, but jlink is a little bit of a cool tool to build your images and also change your image depending on your need. Do you need debug symbols? Do you prefer compressing to a smaller size than sacrificing a little bit of startup time, for example? You can do that. Anyhow, JShell. Next slide. First, we have the AOT compiler on Linux. Pretty nice. And we merged a number of debugging tools into JHSDB. But let's skip to JShell. I was a little bit skeptical at first, like what's the value of a REPL in Java in 2017? But the more I use this, the more infatuated by it have I become. So JShell allows for on-the-fly execution of any Java code. Generates classes. It allows you to tab complete and tab twice to get the Javadoc, etc. So it's a very nice learning tool. It's very nice for exploring APIs and such, and it's just nicely done, I would say. And it's very nice when writing presentations because you can prototype and execute your code as you go along. So JShell is just easy thing to start playing with right away for anyone. Easy to do whatever. Anyhow, I mentioned jlink. So a JDK image is 554 megabyte or so. This is from my Linux workstation. But that's an image of Java or executable of Java doesn't have to be that big. You can, of course, in the old way of having a Java runtime environment that is a slimmed down version of the JDK with the compiler, etc., moved out. jlink just uses Jigsaw modules to go all the way. You can pick and choose any modules that are existing in JDK. You can add your own modules to the module path and build an application that bakes your own application code together with the JDK. So you can have, the possibilities are kind of endless. We're kind of excited to see how this will be picked up and used by end users if chance happens. And jlink, of course, allows, it has a plugin model, experimental by all means, but that allows you to specify various optimizations or doing, injecting code. You can do a lot of things, and we do a lot of, or a few startup optimizations and others using jlink in our build step. So we've been able to optimize away a little bit of the craft that we are initializing when setting up lambdas, etc., and as a means to optimize the platform and potentially applications in the end. So it's lots of cool things and hidden in this little tool. And the last tool that I'll mention is, of course, the jaotc. So it's been a large, many-year effort by our Oracle labs and other involved to. How many have heard about the Graal compiler? Anyone? Oh, one hand. So it's a long research project to build a compiler, JIT compiler in Java, compiling Java code down to native code. So this Graal compiler is now actually shipped with the JDK, especially on Linux, and it's used inside of this tool to generate statically generated native machine code that you link in as a shared library, which is the kind of have the precompiled, statically compiled code for your application. This allows, theoretically and in practice, both speed ups to your startup code, to your startup. It allows for sharing between VMs, etc. of this code. You do work that the JVM would do on every execution. You can do that, ahead of time, and put that in a shared library. It allows a number of pretty good operations optimizations, if you may. It's very experimental as well. Sorry, but there you might have to do some research and trial and error to really get it to work nicely. Anyhow, let's go on to libraries. Time is ticking on here, but so the libraries. On the library sides, when I speak of libraries, it's kind of like the Java util collections, etc. Anything that is part of the core JDK that everyone knows, like Java util list, but so much more as well. You have HTTP servers or whatever, so there's a lot more than just the collections. But the collections is, of course, a big part of the Java ecosystem, and adding some syntactical sugar is often something that is oft requested from developers. Java 9, well, it adds a number of convenience factories that generates immutable literals of collections which is nice and easy in your one-off code or in whatever, but may also be an optimization in certain circumstances. These lists are immutable. They might be backed by a very compact array or something, and may allow the JIT compiler to constant fold, etc. Sorry about that. So they're pretty nice to use and do allow in certain circumstances even for a little bit faster code. But take that with a pinch of salt, because you might also, if you mix and match list.off with array list or God forbid linked list, your call sites might be a little bit confused by seeing more different classes, etc. So if your code is performance sensitive, you should always benchmark and not think that these are in any means a drop-in replacement for writing more performant code, but just simpler, easy, convenient code that should be idiomatic and pretty much as fast as it can be. But there's so many more small core API additions that for me to try and enumerate them all here for you is we're going to run out of time. But there's a huge mass of API or methods added, for example, to Java util objects, to add intrinsical or intrinsified methods for index checking and require non-nulls else and weird things like that. You also have the everyone's favorite, the optional API, which now has a better dealing of with streams, so you can do streams of nullable and whatever. Arrays, if you're writing performance-sensitive code, I'm not sure. Not many people do that, but if you really have to, basing on arrays and the large number of array methods added to Java 9, specifically for performance reasons. So these are lots of small methods appearing all across the standard libraries for optimized and vectorized array operations, which is very important in code pertaining to cryptography or compression in general. But also, small convenience methods like a parse int that takes a car sequence, if you're so entailed. You have the fused multiply add operations, which is one of these operations often existing on like Intel hardware, where you have a hardware instruction for doing a multiply and an add in the same instruction, and by having a specific method for that in the API, we can take advantage of that more easily, which allows for quite insane performance improvements in some corner cases. But taking a more high-level stance, I'm pretty excited about Stream APIs and using Stream APIs, even if they sometimes have a small performance overhead. They're just nice to use, and Java 9 does add quite a bit, or a reasonable number of missed opportunities, like take while, drop while. We have stream.iterate, we have stream of nullable, etc., which are pretty nice too, especially when you have, already lambdafied or streamified code, and you all of a sudden have an optional, or you want to take a stream, etc. It makes it easier in some cases to work or get or bridge between traditional imperative object-oriented code and more of the Java 8 functional programming style paradigm. Looking more at a low level again, something that many were concerned with during the development of Jigsaw and the modularization. So Jigsaw wanted to take away a number of internal or tricky APIs. Like I'm not sure how many have heard of Sunmisk unsafe. Oh, quite a few hands. So most likely all of you have been using it. It's an implementation detail in the JDK to allow for direct memory access and doing explicit memory accesses that like compare and swap things. So these libraries, like any or most application servers or most web servers today have some libraries that are using Sunmisk unsafe to squeeze out a number of percent of extra performance from your code by doing direct memory accesses. These libraries are in a sense a little bit problematic, or deeply problematic, in the sense that they make it very hard for the OpenJDK as a whole to evolve, since there's a lot of code that has deep intrinsic assumptions about exactly how the runtime underneath works. So you have code that is kind of tailored to work exactly or work in unison with say hotspot on Intel hardware. and to try and find a peaceful middle ground between people who are, for good reason, doing performance-sensitive work with SunMISC unsafe, which the JDK architects would like to, remove entirely. We first kind of agreed now that Java 9 does not remove SunMISC unsafe. Libraries that are depending on it will still be able to use it, but we are actively adding features like variable handles that allows for doing much of the same. At least some parts of it, like doing very specific, like type-safe atomic operations, which is one part of what unsafe does for you. So Java 9 has a lot of these somewhat hard to use, but they are more, they are more garnered towards, an SPI. This is API for library maintainers more so than application developers. As application developer, you probably don't have to deal with variable handles or method handles or any of that. If you do, I mean, that's great. But they're really, a way for the JDK and hotspot, etc., to expose complex intricacies of the VM, like how is memory accessed and how do we do memory access on a more hardware aligned manner, but do that safely in a way that will be easy to support and easy to test going forward. So variable handles and all this, I mean, there's a whole universe of things in this area that is pretty exciting if you're into performance. So if you have some questions about that later, I'm happy to answer that as best I can. But low-level APIs and such, we do have lots and lots of small things. We have a pretty big rewrite of the process API with access to the current PID, to access in an operating system agnostic way, access other or listing processes on the system, etc. So there's good historical reasons why this is something that has been dragging its feet a little bit in the Java ecosystem, and as Java or as operating systems are diverging or changing all the time, having direct access to things that are a little bit of might be different on different systems has always been seen as a somewhat problematic thing to do in a virtual machine like the JVM. But I think the process API improvements in 9 does solve and has a good idea on how to do it on systems, like if you're on an Android system or whatever system that doesn't even have a PID, what to return, you might get an exception or such. So read the Javadoc and know that there are operating system specific details in this. Java 9 adds a stack walking API, also a little bit obscure, but pretty nice as a debugging aid. If you want to see, what is the calling method, etc. It's a very nice and performant feature for logging framework providers, etc. Allows you to stream over the stack frames, etc. When you are. But I'll quickly skip over to Incubator modules, which is a new concept. Yay! In Java 9. So Incubator modules, we only have one of those. It's the HTTP client. So we had this long-running project of adding a HTTP2 client, and it was deemed that it was lacking. You know, number of Googlers, for example, had deep technical comments that you know, late in the Java 9 cycle made everyone realize and agree that that the API wasn't really there. It was there in high level. You know, the right pieces are there, but they might not be fitting together exactly as they should. So the incubator module feature is a way of saying that, hey, we are shipping this module even though it's not really there yet. This is a first for the Java platform to explicitly say that this module is probably, or is definitely going to change before it's finalized. But as we're going forward into a 6-month cadence, maybe incubator modules is going to be, you know, a more common occurrence, that will make something available, even though we're not sure that this is the final form of it. Allow for experimentation and feedback early on in the cycles. We know that people aren't, you know, downloading our early access builds en masse, even though we encourage that. Java 10 builds are available. Go fetch. But these, you know, big targeted features that might have a few rough edges are, you know, also a way to communicate that this is things that we are working on, and that could, you know, benefit from both deeply qualified and you know, layman feedback on making sure that that modules are, you know, well behaved and easy to work with, etc. So the HTTP 2 client is, I mean, it's pretty nice as it exists in Java 9. It allows for somewhat reminiscent of some prototypical Ajax RS clients, but it would, you know, it's an easy API to work with, much nicer than the existing or legacy HTTP client in the JDK. So yeah, take it for a spin, but probably not something to depend on in your production system for the time being. Other big developments in the libraries world is a contribution from Victor Klang and company with the Reactive Streams API. Again, a more of a service provider interface or API for writing asynchronous and non-blocking backpressure style flow applications. You might have heard of libraries like akka and logom, etc. And these are trying a finalized attempt or finalized effort to turn or extract APIs and pieces from that are, you know, common to all reactive asynchronous backlog or all those reactive streams style applications and libraries, and try to have an API for that, put that in the JDK. There's no implementation or, you know, existing model or such in the JDK, but rather it's an interface. Think of it as JDBC, for example. So it's an interface for application and frameworks that do asynchronous data streams. I think Ola, who's going to talk after me, has lots more to say on this. Time check. How many minutes? Huh? No worries. Okay. I think my timer started way before I started talking, so I'm at 45 minutes here, but I'm guessing. Okay. So, yeah, now it gets personal here with performance improvements. Under under the covers, lots of things have changed. One of the biggest ones is the compact strings. We have had customers upgrading from Java 6 to 7 and realizing that their footprint grew. Why is that? And performance went down from when going from Java 6 to 7. And are griping. The thing is, in Java 6 by default, we had a feature called compressed strings, which allowed string instances to be one of two classes, but depending on whether or not the string was encodable as a ASCII or Latin 1 string or not. And another implementation entirely if it was, if it really required UTF-16. This helped save footprint quite a bit, and for certain class of applications, this was, really good. And when they upgraded, or those applications upgraded to Java 7, they got sometimes 20, 30, 40% regressions because they had tuned to the performance or the footprint requirements. And if you tune your footprint to be, your heaps to be very, very tight fit for your application workload, and all of a sudden footprint goes up, that can be a very problematic situation for performance. Why was it removed then? Yeah, well, the compressed strings were problematic in many other cases. You had two different implementations that made for a lot of bugs, made for performance bottlenecks in surprising circumstances. You had code that had only seen the Latin 1 strings, and all of a sudden come with a UTF-16 string, and sometimes you had compiler bugs leading to VM crashes, etc. So for various both political and technical reasons, the compressed strings were dropped from Java 7, and it took until Java 9 to redo the effort without the drawbacks of the old implementation that was hacked into Java 6. And I'm pleased to say that all we've seen from performance point of view with the compact strings is that you get the pretty hefty footprint improvement on most applications. Strings that are encodable as Latin 1, which thankfully is what we use here in Sweden. They will typically use almost half as much memory per string. And whereas for UTF-16 encoded Java strings, as you might be aware, are car-based, and a car in Java is a 16-bit integral type. So being able to encode it using bytes instead, a byte array, and then do call site, or depending on, have a coder field in the string to make sure that the byte, or it's unambiguous whether or not the string is byte or car, or technically car encoded. So it's pretty good improvement. We also have what the JEP called indefined string concatenation, and if you go and watch any talks by Alexei Shipalev, a former colleague of mine, you can see statements or microbenchmark results showing that indefined string concat together with compact strings allows, again, take a pinch of salt in microbenchmark, can show you up to 3 times better performance with 6 to 7 times less memory allocation in code that might be, could be performance sensitive, and that's quite a big leap if you're lucky. So I'm not gonna. I don't think I have time to explain what indefine means, but it's using the quickly using the same underpinning. Oh, question? Sorry? I don't hear. Oh, why Latin 1? Yeah, right. Rather than ASCII? It's gone? Oh, right. I think because Latin 1 is a subset of Unicode. So... Oh, you might be right. Now... I'll have to check the details, but I think that the code point by code point, the Latin 1 table, I think matches the Unicode. Sorry? Right, but I think the euro symbol is defined later in the Unicode template, so Latin 15 might have. There was some good technical reason I don't remember. I can look it up. Right. So the internal representation here doesn't, it doesn't care about your car set coding or whatever. It makes sure that it just makes for an unambiguous mapping from string data to such. We can we can discuss this after. I think. So there were lengthy discussions about what to use instead of. I mean, should you use ASCII or which Latin one encoding should be used, etc. But still, right. In the string concat, yeah, we use the same underpinning mechanisms for that backs lambdas and method references from 8. Uses something called method handles internally, and this is all in a package called javalang invoke for invoke dynamic. So the bytecode is invoke dynamic, and then someone verbified it into indify to make code use invoke dynamic is to indify. I'm not sure it's gonna catch on, but that's where that weird word comes from. Right, we have quite a big leap in cryptographic performance in 9, which might be very interesting for some people. So we've collaborated a lot with Intel in particular to work on intensification, vectorization of various math operations that are important to make certain crypto libraries work faster. So there's everything from general purpose optimizations in big integer math libraries, so which are then used by various crypto, and there are very specific like AES using specific intrinsics for certain methods that are using. So on Intel hardware, there's now a set of instructions that are tailored for certain hash algorithms. So there's lots of silicon on your chips that are serving a very singular purpose, and it would be a waste not to utilize it. So Java 9 is better to make use of these things that Intel are graceful enough to shove into their CPUs for us. And well, to sum it up, we also have a number of weird changes or good changes. G1, the garbage collector. Who knows what a garbage collector is? So G1 was introduced quite some time ago and has been the stepchild of many a GC engineer over a number of years now, and finally, well, both engineers and product management has seen that in general, G1 is typically the better default for most users than the alternatives. G1 is, a region-based, complex, concurrent marking garbage collector, which serves to keep your pause times small. It might not be as throughput performant as the previous default, the parallel old. So on certain applications, people are reporting, if you have a batch style application that is, processing a lot of data and that's all it does and then it quits, this is probably a bad default for you. I'm sorry, but for many general purpose applications, G1 behaves on average much better. Again, it might require a little bit more heap heap space than the parallel to work optimally. So if your application is very tuned to your very snug fit heap, and suddenly the garbage collector implementation changes, could be a problem. So make sure that your applications aren't running into unexpected amount of garbage collector activity. It should be typically less than 2% of the CPU load. Anyhow, a startup story with using jlink to statically generate, so this invoke dynamic thing that was added to Java 7 and re-engineered in Java 8 and has been improved immensely in Java 9 to support the dynamic bytecode, which was originally thought to we need this to support Python on the VM or Ruby on the VM, and nowadays it's it does serve that purpose and does it pretty well, but it also underpins lambdas. If you're using lambdas in Java 8, you have method references, etc. So it uses a dynamic mechanism at runtime to generate lambda forms and lots of. So there's a little bit of standard Java class file generate or bytecode generation in runtime to support these lambdas. And a project that I did for Java 9 was to experiment with using jlink to here we have an application that is doing a lot of lambdas, and if we take a trace of that and try to see what parts of that dynamic lambda machinery could we generate statically and do that at link time, something you can actually play with the plugin. But in general, it serves to make it so that Java 9 is considerably faster to start if your application includes lambdas or any such Java 8 style code. I usually say this first before saying that sadly startup in Java 9 is a little bit worse than Java 8 in general, thanks to the module system itself, which does a little bit of bootstrapping. But we already cut that down by about 20-25% for Java 10. So if there's looking clear skies ahead. Other than that, I'm running out of things to say here. We have, as part of the Java Lang invoke indify optimizations, we've seen up to 4x improvements in some NASORN benchmarks. You might see the same on, JRuby and other script or dynamically interpreted languages running on the JVM. And there's, there's lots and lots of other optimizations about. So I think I'll pause there. I have a few more slides, but they're mostly random ramblings. So unless I'm stopped here, going once, going twice. Any questions before we hand over? I'm not sure if we have time for a Q&A. Yeah. If there are anyone, so I would love to circle back to that guy who asked about Latin 1. I'll have to do a few quick Googlings first to find the discussions that are already taking place on the subject. I'm sorry. But okay, I'll hand over. Thanks.